human beings have been living on this planet Earth since the time immemorial, and scientifically speaking, since about 2 to 3 lakhs years ago. As discussed in the previous sessions, the Earth originated years earlier, that is, around 4.6 billion years ago. We got to know about the story of origin and evolution of the Earth and how the present continents and oceans have got their current position. We also got to know about the interior layers of the Earth. Let us try to know few more things about the phenomena that take place on the Earth. Have you ever given a thought that does the Earth remain in the same manner or things change on it? The Earth has neither been the same since its formation, nor will it remain the same in the coming times. Some or the other movements and subsequent changes are taking place even now, either on the surface or below it. Some of these changes take place suddenly, whereas others gradually. For example, earthquake and volcanic eruptions happen suddenly, whereas erosion takes place gradually. In this session, we are going to talk about one such sudden movement that takes place on the Earth's surface. It is earthquake. We all have heard about the earthquake, right? Many of us must have experienced it also. An earthquake, in simple terms, is shaking of the earth. Oh, this way. But why does the earth shake? We discussed about the earth's interior and the movement of magma inside it. The shaking of the earth is caused due to release of energy from the interior of the earth. This release of energy generates waves that travel in all directions, creating vibrations on the surface. These vibrations are known as the earthquake. You must be wondering, where does this release of energy from inside the earth occurs at? The release of energy occurs along a fault. And what is a fault? A fault is a sharp break in the rocks present in the earth's crust. Rocks along a fault tend to move in opposite directions. As the overlying rock strata or layer presses them, the friction locks them together. However, their tendency to move apart at some point of time overcomes the friction. As a result, the blocks get deformed and eventually they slide past one another abruptly. This causes a release of energy, and the energy waves travel in all directions. These energy waves are nothing but earthquakes. So, as explained, the most important cause of earthquake is tectonic activity. Another important cause behind the occurrence of earthquake is volcanic eruptions. When volcanoes erupt, earthquakes occur in the nearby areas. Such earthquakes are known as volcanic earthquakes. The third important factor behind occurrence of earthquakes is the pressure exerted by large reservoirs. Other human-made factors such as blasting etc. also cause earthquakes. Though these energy waves travel in all directions as earthquake, there is a point from where the energy is released. This point is called the focus of the earthquake. It is also called the hypocenter. The energy waves traveling in different directions reach the surface. The point on the surface nearest to the focus is called epicenter. It is the first one to experience the waves. It is a point directly above the focus. All natural earthquakes take place in the lithosphere, that is up to 200 km of depth from the surface of the earth. Sometimes the shaking of the earth or the earthquake is mild and we experience just shakiness in the ground. But at several other times, severe and intense damage to lives and properties is caused. But the question arises, how do we record an earthquake? An instrument called seismograph records the waves reaching the surface. A curve of earthquake waves gets recorded on the seismograph. You can see here that the curve shows 3 distinct sections, each representing different types of wave patterns. As you can see in the graph, various names are there for waves. Earthquake waves are basically of 2 types. One, body waves, and second, surface waves. We will try to understand the characteristics of these 2 waves one by one. At first, we will try to know about body waves. Body waves are generated due to the release of energy at the focus and move in all directions traveling through the body of the earth. Hence, they get the name body waves. The body waves interact with the surface rocks and generate new set of waves called surface waves. That is the second type. As the name suggests, these waves move along the surface. Do you think these waves travel with the same velocity throughout? No. The velocity of waves changes as they travel through materials with different densities. The denser the material, the higher the velocity and vice versa. Not only velocity, but their direction also changes as they reflect or refract when coming across materials with different densities. Let us know more about body waves. The body waves have 2 categorizations depending upon the characteristics. These 2 types of body waves are P wave and S waves. P waves move faster and are the first to arrive at the surface. These are also called primary waves. The P waves are similar to sound waves. They travel through gaseous, liquid and solid materials. S waves, which are another type of body waves, on the other hand, arrive at the surface with some time lag. These are called secondary waves. An important fact about S waves is that they can travel only through solid materials. This characteristic of the S waves is quite important. It has helped scientists to understand the structure of the interior of the earth. Did you know the surface waves are the last to report on seismograph? These waves are more destructive. They cause displacement of rocks and hence the collapse of structures also occurs. While the seismograph records the earthquake activity, the magnitude or intensity of earthquake is recorded in another manner. The earthquake events are scaled either according to the magnitude or intensity of the shock. The magnitude scale is known as the Richter scale. You must be wondering, what is meant by magnitude? The magnitude relates to the energy released during the quake. The magnitude is expressed in numbers 0 to 10. The intensity scale is named after Mercalli, an Italian seismologist. The intensity scale takes into account the visible damage caused by the event, and the range of intensity scale is from 1 to 12. I will share with you a very interesting fact. Now you know that earthquake waves get recorded in seismographs located at far off locations. However, there exist some specific areas where the waves are not reported. Yes, there are a few such areas. Such a zone is called the shadow zone. The study of different events reveals that for each earthquake there exists an altogether different shadow zone. You can see the shadow zones of P and S waves. It was observed that seismographs located at any distance within 105 degrees from the epicenter recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degrees from epicenter record the arrival of P waves, but not that of the S waves. Thus, a zone between 105 degrees and 145 degrees from epicenter was identified as the shadow zone for both the types of waves. The entire zone beyond 105 degrees does not receive S waves. The shadow zone of S wave is much larger than that of the P waves. The shadow zone of P waves appears as a band around the earth between 105 degrees and 145 degrees away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is also a little over 40% of the Earth's surface. Now you know lots of things about earthquakes. Let us know the distribution of earthquakes, or whether there are any specific areas of occurrence of earthquakes. Though earthquakes can take place anywhere, but the frequency of earthquakes is confined to certain specific areas. As mentioned, earthquakes occur due to tectonic activities. So, the plate boundaries are prone to earthquakes. The other areas where earthquakes occur commonly are the areas of volcanic activities. These two zones happen to correspond with the inner circle of the Pacific Ocean, known as the Pacific Ring of Fire. Earthquake is generally a natural hazard. This means it takes place naturally. The effects of earthquakes are far-reaching when the severity is more. The immediate hazardous effects of earthquakes are ground shaking, differential ground settlement, land and mudslides, soil liquefaction, ground lurching, avalanches, ground displacement, floods from dam and levee failures, fires, structural collapse, falling objects, and tsunami. Though many of the effects of earthquakes cannot be stopped, but these damages can be reduced with the help of proper and timely prediction and warning. This is known as management. The management of earthquake as a hazard can lead to reduced casualties and loss. Now let us recapitulate what we learnt about earthquakes by answering few questions. First one is, which of the following earthquake waves is more destructive? First, P waves. Second option is surface waves. Third option is S waves. And fourth option is none of these. The second question is that of the fill in the blank. Blanks is the area where most of the earthquakes occur. Third question is, choose the correct combination to fill in the blanks in the sentence. The place where an earthquake originates is called the blank, and the area just above it on the surface of the earth is called the blank. Now you have to choose between these three options. The first blank is focus and the second blank is epicenter. The second option is epicenter and focus, and third one is none of these. The fourth question is, the earthquake is recorded on the instrument called blank. The first option is Richter scale, second is seismograph, and third is both. Learners, I hope you must have understood the phenomena of earthquake. In the next session, we will come up with another topic, that is volcanoes. Till then, try to collect pictures of earthquakes that have occurred in India in the last 20 years and analyze how severe they were.